Hello students, good morning everyone. Today let us learn about the concept of ultrasonic flow meter. Okay, so in the last class or in the last video we have seen that different types of variable area types. So in that rotameter and also we are discussing about the variable head type of venturimeter and orifice plate, and also we are discussing about Reynolds number, turbulent flow, laminar flow, and also we have seen that the comparison or difference between the laminar flow and turbulent flow. So what is the flow meter? What are the classifications of flow meter or flow measuring techniques? So let us learn about today's class or today's video. We will discuss ultrasonic flow meter. So in ultrasonic flow meter is divided into two types. First one is the time difference type. Second one is the Doppler flow meter. So first we will discuss time difference type. So in time difference type, operating principle as shown in the figure, you can observe the diagram. The flow meter is based on the apparent change in velocity of the propagation of ultrasonic wave pulses in a fluid with change in velocity of the fluid flow. So what is that operating principle? The flow meter is based on the apparent change in velocity of the propagation of a ultrasonic wave pulses in a fluid with change in velocity of the fluid flow. So at the input side you are having what? Some flow. So inside you are having what? Some particles or fluids or bubbles. So it will change of that velocity. Once you are going to apply that velocity of the flow, it will changes the direction of that particles. Okay. So next we will discuss the construction and working of time difference type. The figure shows the construction of time difference type ultrasonic flow meter. So first it consists of two transmitter and two receiver. It consists of two transmitter and two receivers. These are separated by distance L as observed in the diagram or as shown in the figure, separated by distance L, and the angle theta is mounted along the pipe axis as shown in the figure. Angle theta mounted along the pipe axis as shown in the figure. So next point, the transmitter A transmits the wave pulse in the direction of receiver A and the wave as it is in the direction of the flow. So whatever you can transmit, the A transmits the wave pulse in the direction of the receiver A, the wave as it in the direction of the flow. So it is same as whenever you are going to apply your transmitter A pulse, it is same as your receiver A. So both are in the same direction. The transmitter B transmits the wave pulse in the direction of the receiver B. The wave is opposite to the direction of the flow, because whatever you are going to observe in the diagram, so transmitter B opposes to the transmitter B will be, the transmitter B transmits the wave pulse in the direction of the receiver B. The wave is opposite to the direction of the flow. Okay, so both are in the opposite direction, transmitter and that of the flow. So whatever you are going to send, that flow of that velocity and the transmitter B will be the opposite direction. So that's why you can say the wave is opposite to the direction of the flow. The velocity of the ultrasonic wave increased or decreased by the fluid velocity. The velocity of the ultrasonic wave increased or decreased by the fluid velocity depending on the direction of the fluid. Depending on the direction of fluid. You can increase or you can decrease. So depends on direction of the fluid. The transit time given by the time for ultrasonic wave to travel from transmit A to receiver A is given by TA. So how much time will taken by transmit A to receive A is given by TA is equal to L divided by C plus V cos theta. Time for ultrasonic wave to travel from transmitter B to receiver B is given by TB is equal to L divided by C minus V cos theta. So because minus, you have to consider it is in the opposite direction of that original flow. So plus you have taken because of both are in the same direction of the velocity of the flow. Okay, so that's why you can consider how much time is required for transmitter A to receiver B and transmitter B to receiver B, transmitter A to and receiver A. Okay, so just you have to calculate the time taken for what to reach transmitter A to receiver A and transmitter B to receiver B, where L is the distance between transmitter and receiver, V is the velocity of the ultrasonic wave, theta is the angle of the path with respect to pipe axis. Theta is the angle of the path with respect to pipe axis. Next, V is the velocity of the fluid flowing through the pipe. Velocity of the fluid flowing through the pipe. Next point, that is the last point of this time difference. The difference in time between TA and TB is given by the difference in time between TA and TB is given by delta T. You can say take on variable delta. Delta is a change, so that's why TA minus TB is given by put the value of TA and put the value of TB. L divided by C plus V cos theta minus L divided by C minus V cos theta. So we are getting the one equation, delta T is equal to L divided by 2V cos theta. So replace that V by delta T. So just cross multiply this one. You can take the top side of the V and again you can divide that delta T. So L divided by 2 delta T cos theta. So this is the original equation which comes under what? Time difference type with respect to ultrasonic flow meter. So second one, in ultrasonic flow meter, Doppler flow meter operating principle. So flow meter is the based on Doppler principle, as we can observe in the diagram. Okay, so based on, you can take one example, Doppler principle, take on train and you can waiting for that train. So waiting for train, that person should be what? Source, and coming that train should be, that is the destination. So whenever your train near to comes, you can hear the frequency more, and whenever it will away from you, that person and train, so that will be the frequency should be decreases. So that is the Doppler principle. Okay, so based on whenever your frequency increases, so that time your train should be nearer to come to that person. So whenever your train away from that person, so that time your frequency should be decreases. So like that Doppler principle will be work. Okay, so next, as shown in the diagram, first point, the figure shows the construction of Doppler flow meter, in which one crystal transducer is mounted outside the pipe as shown in the figure. One crystal transducer is mounted outside the pipe as shown in the figure. This transducer emits an ultrasonic wave, and the wave is at an angle theta through the pipe. So you can strike or you can send one ultrasonic wave. Okay, so emits the ultrasonic wave and the wave is at an angle theta through the pipe. With respect to theta, you are having one angle. The transducer is basically piezoelectric crystal. The transducer is basically piezoelectric crystal. The some parts of the ultrasonic wave are reflected by the liquid particles and the bubbles. So inside this pipe you are having what? Particles and bubbles. The pipe wall, it is returned through the pipe wall towards the transducer. Some parts of the ultrasonic waves are reflected by the liquid particles and the bubbles. It is returned through the pipe wall towards the transducer. So whenever you are going to send your ultrasonic wave, it will emits your wave enters into the what? Your inside the pipe. What will happen? Inside that particles and bubbles are reflected towards that pipe. As the liquid flows through the pipe, the particles and bubbles in the liquid also move in the particles, act as a reflectors for the ultrasonic wave. So as the liquid flows through the pipe, the particles and the bubbles, so whatever that inside the pipe, you are having what? Particles and bubbles in the liquid also move in the particles, act as a reflectors for the ultrasonic wave. And the velocity of the flowing fluid through the pipe is given by one equation, V is equal to delta FCT divided by 2F0 cos theta, where V is equal to velocity of the fluid, delta F is the difference between the transmitted and receiver frequency, CT is the velocity of the ultrasonic wave, F0 is the frequency of transmission angle between the transmitted wave and the pipe axis. Next, as CT, F0 and theta are constant, you can consider or you can assume CT, F0, theta are constant, the velocity of the fluid is directly proportional to the difference between the frequency, that is V is directly proportional to delta F. So this is the final equation comes under what? F, that is the delta frequency, change in the frequency. As you know, it may be increase or decrease, depends on, I was given one example with respect to train and person. Okay, so next advantages, first one is the good accuracy, second one is the fast response, third one is the no pressure loss, fourth one is the suitable for liquid and gases. Disadvantages, cost is high, circuit is complex, applications. It is used for liquid flow. It is used for liquid without any pressure loss. So next we will discuss miscellaneous type. So in that, electromagnetic flow meter. It is also one of the type of what? Your flow meter or flow meter techniques. So what is the operating principle? So electromagnetic flow meters works on the principle of Faraday's laws of electromagnetic induction. You know that is Faraday's law, which states that so whenever conductor moves through the magnetic field of a given field strength, EMF is induced in a conductor proportional to the velocity between the conductor and magnetic field. So electromagnetic flow meter works on the principle of Faraday's laws of electromagnetic induction, which states that whenever conductor moves through the magnetic field of a given field strength, EMF is induced in conductor proportional to the velocity between conductor and magnetic field. So as we can observe in the construction working, so this is the diagrammatic representation of what? Electromagnetic flow meter. Figure shows construction of electromagnetic flow meter. Second point, the magnetic flow meter consists of non-metallic portion of the pipe, which is made up of fiber glass. It's the non-metallic portion of the pipe which is made up of fiber glass, as you can observe in the diagram. The pair of electrodes are mounted opposite to each other and inside the wall of the pipe carrying liquid whose flow is to be measured. Pipe is placed within electromagnet which produces magnetic field. Pipe is placed within electromagnet which produces magnetic field, which is generated by current flowing through it. Current flowing through it through coil placed on the electromagnetic. Coil is powered by steady DC supply. You can apply for steady DC supply. You can observe in the diagram also. As fluid passes through the pipe, so this is a very important part. As the fluid passes through the pipe, according to the Faraday's laws of electromagnetic induction, EMF is induced. So that is very important. EMF is the induced. So whenever your fluid passes through that pipe, as per laws of Faraday's, EMF is induced across electrodes and proportional to the velocity of the fluid, and it is given by EMF is equal to B into L into V. So here B is the flux density, L is the length of the conductor, and V is the velocity of the conductor. And last point, therefore, the constant magnetic field, magnet of the EMF induced across the electrodes will be directly proportional to the velocity. So this is the working and construction of electromagnetic flow meter. So this is the concept of miscellaneous type. So next we will discuss the advantages. It provides wide linear range. It provides rapid response to flow changes. Disadvantages: high cost, not suitable for low velocity. Applications: it is used to measure the flow in chemical industries. Used to measure the flow in food industries. You can use for what? Chemical and food industries. Comparison between orifice plate and venturi meter. So first parameter, working principle. You know working principle of orifice meter and venturi meter. You can observe. Construction, you know, it consists of three types of orifice plates are used in concentric, eccentric and segments. It consists of three sections like converging, throat and diverging. Next one, maintenance, more and less. Cost is low and high. Application, useful in chemical, food and industries, used to measure the volume flow of blood through vessels, water waste applications. So next we will discuss difference between time difference and Doppler flow meter. So in time difference works on the principle of velocity modulation of the ultrasonic wave, works on the principle of reflection of the ultrasonic wave. Second one, two pairs of the transmitter and receivers are used. Single pair of transmitter and receivers are used. Third one, bidirectional flow measurement is possible. Flow measurement is only one direction is possible. Useful in wastewater application, useful in chemical industries. Next difference is the orifice and electromagnetic flow meter. These all are very important in your final exam. Differences they will ask anyone. Types of liquids of gas are water and gases, conductive liquid. Range small, it is a large. Pressure high, very small. Loss of viscosity low and high. So this is the today's class. We completed the 5th chapter. Okay, so in that, from the first class we are discussing about the flow, fluid, viscosity, properties and characteristics, types of flow based on Reynolds number, based on turbulent flow and laminar flow, and difference between the laminar and turbulent. And also we are discussing about the flow meter definition, classifications of the flow meter, that variable head type, variable area type, positive displacement type, miscellaneous type. Okay, so also we are discussing about the detailed construction and working of all the types. Okay, so this is the very important chapter which comes under in your real time applications. Okay, so I hope you people will understand this concept. Thank you.